Okay, let's talk about how to find limits graphically. If we look at the first question, limit as x approaches -3 from the left side, that means we're looking at the graph as it approaches the x value of -3 from the left side. Now remember, the answer that goes here for all of these questions are going to be what y is approaching. So they're all y values. These here are all the x values. So let's erase this guy now. Let's look at what happens as x approaches -3 from the left. As x gets close to -3 from the left, the y value is getting closer and closer to 1. Similarly, as x approaches -3 from the right side, and again, don't worry about all of this part of the picture. All you're caring about is as you get as close to 3 as possible, -3 as possible, which is like here. Remember, we want to get close to -3. Yes, all of this, but you don't have to look out here and follow the whole path. Remember, limit means how close can you get without touching it. So I often get the question is like, oh, well, which piece do I look at? Well, just look around -3. Just look around -3, and that's where you want to be. As you get close to -3 from the right side, the y value is also approaching 1. Now remember the rule. If there's no direction, that means the limit on the left has to equal the limit on the right, which in this case are questions 1 and 2. They're the same, so the answer is also 1. Now, number 4 is value. Where is the graph? Where does it have a value at -3? So you look at -3 and you look along the line. Are there any places along the line where there's a y value that is actually defined at -3? No. So the answer is D, N, E, because it does not exist. Okay, so now let's look at -1. -1 right here from the left side is this direction. So as x approaches -1 from the left side, the y value is getting closer and closer to -2. Now we look on the right side. As x gets close to -1 on the right side, the y value is getting closer and closer to 3. Okay, now notice that number 7, there's no direction. So you look at the left and the right. Are they the same? No. So it does not exist. Number 8 has to do with value. So you look at -1 and you see where is there actually a value at -1, a y value. Well, when I come down here, I see there's a dot, a filled in point. When I come up here, I see it's an open circle. So that means there's no value at this part, but there's a value here. There should only be one because it's a function. And the value, the y value, will be -2. Now let's look at as x approaches 2 from the left side. Here's 2. As you approach 2 from the left side, the y value is getting close to 2. As you approach 2 from the right side, the y value is getting close to 1. Now, to answer number 11, does the left and the right go to the same number? No. So therefore the limit does not exist. Now let's talk about value, which is number 2, 12. At 2, it's defined here, which has the y value of 1. Now let's look at x approaches 4 from the left side. Here is 4. As you approach 4 from the left side, your y value is getting closer to -1. As you approach 4 from the right side, your y value is also getting close to -1. They're the same. So as x approaches just plain old regular 4, the answer is -1. Now we talk about value. Value is right here. Now you may see, but there's no black dot like all the other places. No, there doesn't have to be. As long as the line goes through it, there's a value there. The only time you can say there isn't a value is if there's holes somewhere. So it's valued at -1. Just note real quick that you have a limit and a value, and they're the same. So when we talk about continuity, those are the 3 components of continuity. There's a value, there's a limit, and they're the same. Let's look now at the limit as x approaches 6. So as x approaches 6 from the left side, the y value is getting close to 1. As x approaches 6 from the right side, it's also getting close to 1. Since they are approaching the same number, the limit as x approaches 6 is 1. And we talk about value at 6. Now notice, though the limit is approaching 1, the value isn't. The value is defined up here at 3. Now in the last question it says, what possible values of x, list all the values of x of which f of x is discontinuous. Remember, that means you have to have a value, you have to have a limit, and the value has to equal the limit. So let's look at the pieces that we, on the graph. So you're going to look at holes, you're going to look at jumps, you're going to look at possible asymptotes, which we don't have here. So let's look at the first part, which is at -3. At -3, there's a limit. So the limit part works. But you notice what doesn't work is there's no value. So to answer 21, I'm going to answer it up here. The function is discontinuous at x is equal to -3 because the value does not exist. Let's look at -1. It is discontinuous at -1 because if you remember, at -1, the limit did not exist. Just to go back to at -3, remember the value didn't exist. Let's look at here, at 2. At 2, the limit didn't exist. There is a value, so the limit does not exist. Let's continue. Well, 4, there was a value limit. They were the same. We said it was here, so that is continuous. The next one happens at 6. Is there a value? Yes. Is there a limit? Yes, right here. See, limit, value, but fails the last one. See, the value is 3. The limit is 1. So the value does not equal the limit. So to answer 21, there are 4 places of discontinuity. The 4 places of discontinuity are -3, -1, 2, and 6. And also just recall that we have names for these type of discontinuities. At -3, this is removable. At -1, it is a jump. At 2, it's also a jump. And at 6, it is removable. Okay, so removable, jump, jump, removable. So hopefully this helps clarify your questions on limits graphically.